Hello ELM 258 students. This is a tutorial for Virtual Lab 6, and what we're going to do is we're going to use the first circuit from Virtual Lab 5, which was the ABC actuators. So it should look like what I have on the screen, and we're going to use it to do some troubleshooting exercises and introduce various types of faults into the system and see what effect those have on the performance. Before we do anything, there are a couple things we need to do, one of which is to save the project as a new name, and I'm just going to call this Virtual Lab 06. That way, just in case you have to go back to Virtual Lab 05. And then I want to make sure the simulation still works. So if you click Run Simulation, press the Start button, you should see actuator A, B, C, extend, and then CBA retract. Okay, so now we can continue with the modifications. I'm going to make some additions to the circuit to make it work a little more realistically like the HAS 200. So we're going to add a power switch to turn the 24 volts on and off. We're also going to add a pneumatic valve to turn the air on and off. So let's work on the power switch first. So what I'm going to do is disconnect I'll just delete this one completely. And then this one I could pull out here, disconnect it. I think I'll move this whole thing over a little bit. And I'm just going to get a regular switch, a toggle switch from the electrical control area. And remember, we're using the IEC standard. So if you open that up, there are the switches. And what we're looking for is a normally open toggle switch. Bring that up in here. And we'll just call it main power. And I'm just going to zoom in a little bit. So we're going to rotate that right, connect it here, connect it over here, and also to the common of the outputs. Now it's not exactly like the HAS 200 because what we're doing is directly switching the 24 volt DC. On the HAS 200, the power switch controls the AC voltage, which then supplies a DC supply, but the effect is going to be the same. All right, let's move down here and add the pneumatic valve. So let me zoom out. So I'm going to go zoom previous, see the whole thing. So I'm only going to need one pneumatic pressure source. So I'm just going to pull this down, delete the line that's connecting it, and then move this over. And I'm just going to delete these because I'm going to then supply all the air through a single valve. All right, so we're going to go over here to pneumatic and go to directional valves, and this is going to be a 3-2 normally closed valve. And we want the type that has a little lever on it that is spring loaded, but when you click the lever it'll stay in position. So I'm just going to bring this up here, rotate it to the right. I'll just kind of tuck it in down here. So the way this is working, I need to rotate this also. Connect the air pressure source there. And I need an exhaust for the other port. So we'll go over here to get, I think it's under pneumatic. Here's the exhaust. Let me zoom in a little. I'm going to zoom in a little bit so you can see what I'm doing here. So in this normal position, the air that's connected here is going to exhaust out of the valve. And I'm just going to connect this up to the 3 control valves. So this is kind of like on the HAS 200, the valve manifold, which has all the valves all in one place, have one common pneumatic pressure source, and there's a little valve on each station that opens and closes to allow the air to flow in. Okay, let's go to previous zoom, see the whole thing. So we should have an electrical power switch and a pneumatic air valve. Okay, now we're going to run the simulation and make sure everything works after we added the power switch and the pneumatic valve. So this, now that we have those switches in, now whenever you start the simulation, you got to click the power switch and also the pneumatic air valve. And you should see the lines turn red, which means they have compressed air. So hit start and it should go A, B, C, and then C, B, A in reverse. Okay, so you're going to do some troubleshooting exercises, and I'm just going to demonstrate a couple of them. So in some of them, you're going to disconnect an output and see what effect that has on the process. So I'll go ahead and disconnect the line. So you would just click on the line that connects. Let's say if I want to disconnect C+, delete it, and then run the simulation. Remember, you got to click the power switch and the pneumatic valve each time. Then when we run it, you'll see that the process is going to go to a certain point, and then it's going to stop. And it should be pretty obvious, why this is stopping. The PLC is telling C+ to actuate, but there's no electrical line connected. So C+ is just sitting there. The valve is not getting its signal to actuate to the C+ position. All right, so that's how you would disconnect an output. And let's reconnect. So each time you do it, you're going to reconnect the line and just rerun the simulation. Remember to click the power switch and the pneumatic valve and make sure everything is good. Okay, and so you're going to do a similar thing with the sensors. So if I were to disconnect, for example, sensor C0, you would just click the line that connects it to 24 volts and delete it. Now that sensor is disconnected. Run the simulation. Click power switch, click the pneumatic switch. Okay, and now when we hit start, see A, B, C goes, and then C retracts, and then you notice that B is kind of stuck there. So that's a case where we've got an input fault that's preventing the next step in the program from executing. So that's pretty much it. You're going to disconnect various outputs and inputs, try the process, observe where it stops, and then describe that, and then explain why. What's going on? Why is it stopping at that point?